The connection between energy, heat, and temperature is based on a series of assertions about the atom. These are atoms are the smallest unit of matter, atoms are always in motion, this motion is kinetic energy, and atoms can exchange energy, allowing heat to flow from regions of higher temperature to regions of lower temperature. Building on our understanding of heat, we looked at how this relates to the presence or absence of temperature changes as water absorbs or releases heat. This representation of the relationship between temperature and energy shows that temperature changes with the absorption or release of sensible heat, except during phase changes when latent heat is absorbed or released without a change in temperature. The sensible heat changes are the sloped lines between the phase changes. The latent heat changes are the flat regions as the phase changes occur. Because we know the units on this graph, we can quantify these relationships and define the actual amount of energy required at all of these steps. In fact, we already know one of these values. Since the calorie is defined as the amount of energy required to raise 1 gram of water 1 degree C, we know the amount of energy required to change the temperature of water. This is called the specific heat of water. More generally, specific heat is defined as the calories required to raise 1 gram of a substance 1 degree C. By definition, the specific heat of water has to be 1. As we will see in a minute, this is an unusually high specific heat, meaning it takes quite a bit of energy to change the temperature of water. You'll notice that the slope of the line showing the change in temperature per unit change in heat for liquid water is much shallower than it is for either ice or water vapor. The slopes differ because both ice and water vapor have lower specific heat values than liquid water. The specific heat for ice is 0.5. This means an amount of energy that would raise a volume of water 1 degree will raise the same volume of ice twice as much. Steam also has a specific heat value that is only about half that of water. Heat associated with different phase changes can also be quantified. The energy associated with the change from ice to water is called the latent heat of fusion for water and has a value of 80 calories per gram of water. Heat associated with the transition from liquid water to vapor is called the latent heat of vaporization, and for water, it is 540 calories per gram, which is a lot of energy. Getting back to the question about which is worse, a burn from 100 degrees water or 100 degrees steam, the high latent heat of vaporization for water, indicated by the length of the flat line between water and vapor, suggests that the burn from steam is much worse, because water vapor has 540 more calories of energy per gram than liquid water at the same temperature. The specific heat of other materials can also be calculated. Here are the specific heats of some representative materials. Air has a specific heat of 0.17, aluminum 0.22, glass 0.16, ice we've already seen with a value of 0.5, lead much less than 0.1, soil 0.2, steam again at 0.48, and finally water by definition, which is with its value of 1 calorie per gram degree Celsius. Notice that this value stands out. Ice and steam are closest at about 0.5 and everything else is much lower, showing that water has an unusually high specific heat.